Hey guys, this is we got two videos for today. Okay, first one's going to continuation of 12.5, and the second one is on something new called Heroes Formula. This 12.5 stuff can get really interesting. Some of these problems can get kind of cool, sometimes very challenging. You know, there's two problems in this document. If you would like to try them yourself, that would be great. I will tell you that they're not easy. Okay. And you know, you have to stick with it a little bit. Okay. Uh, Answer for the first one comes out to 9/28. So if you want to jot that down and try to do it yourself, that would be awesome. If you Answer for number two is 9/25 to 15/15. So if you want to jot that down as well, that wouldn't be a bad idea, because you trying to do these on your own first is going to be really important. Then watching what I do will help, and that'll help you tremendously in doing the problems for the homework, I believe. Okay? So I'm going to go here. So if you want to stop and try yourself, that'd be awesome. But let's take a look here. So AE to EC is 3 to 4. So I don't know what the lengths are, but I know it's 3 to 4. And what you're looking for with a lot of these problems is you're looking for, you know, again, shared height or shared base, you know, same height, whatever, you know, something like that. And sometimes similarity, but you know, there's different things you got to look for here. So, you know, let's see what we can do. Okay. First of all, you know, because of these lines are parallel, triangle AED is similar to triangle ACB, right? So the ratio of the areas is the same thing as the square of the corresponding sides, right? So we're looking at 3 to 7. So for the sides, so the areas would have to be 9 to 49 of those two triangles, the little one on the top, AED, and the whole thing. We're going to come back and use that idea, use that 9 to 49 in a little bit. Okay? Now what I want to do is I want to take a look at these two triangles here. You see, these two triangles, we know that that this side to this side is 3 to 4. But we also know that they would have the same invisible height. It would be here someplace. You see, that's the height of this triangle up top, but it's also the height of this triangle using this as the base. So they have the same height. Okay? That means the ratio of their areas is the same as the ratio of their bases, right? Okay. Okay, let's see what we can do here now. So here we have, sorry about that. So here we have the ratio of these areas has to be 3 to 4. Okay, has to be 3 to 4. And some multiple of that. Now remember, let's go back to what we did earlier. We know that this top one, we can kind of call 9 to the whole thing of 49. Okay? So that's why I'm writing 9. I'm writing 9y in there because the ratio of this top thing to the whole is 9 to 49. Now remember, what did we just say about these two triangles? Their areas have to be the same as the ratio of the bases, 3 to 4. So if we call this one 9y, this one would have to be 12y, right? And if that's 12y, and this whole thing is 49, this has to be 28y, because 9 plus 12 plus 28 is 49. So to find the ratio of this little triangle to this triangle down here, it would end up being 9 to 28. Okay? That one's tricky. So we're kind of using this little triangle to the big one and these two little triangles, how they relate to each other simultaneously, and then pulling everything together. All right? So, pretty cool. Again, I hope you tried it first yourself. And then this one down here, we kind of use some of the same ideas, and some of these ideas will be used in your homework for sure. So take a look at, you have a trapezoid, you have 4 triangles, but I hope you're seeing right away that triangle 1 and 2 are similar because of alternate interior angles. Okay, and the ratio of their sides is, so triangle 1 to triangle 2, sides are 6 to 10 or 3 to 5. That means the areas must be 9 to 25. Okay? So I'm going to call this like 9y and this 25y. And that's just based on those things being similar. All right. So now let's go back to, we have to relate 3 and 4. So take a look at these 2 triangles here. These 2 triangles have this shared invisible height right here. Okay? So the ratio of their areas must be the same as the ratio of their bases. Well, we actually know what the ratio of their bases are. Remember, their sides are 6 to 10 or 3 to 5. So that means, and this side corresponds to this one. So that means that's, 3x to 5x. Okay? So that means these 2 triangles that have the same height, the ratio of the areas has to be the same thing as the ratio of their bases. Their bases are 3 to 5. Here we called this area earlier 9y. That's this times 3. So if this is 15, multiply it times 3, this in here has to be 15y. Okay? And now you can do the same thing using these 2 triangles. It's the same thing. This side to this side is 3 to 5. These 2 triangles have the same invisible height. Ratio of their bases must be, ratio of the areas must be the same as the bases, 3 to 5. If we call this 9y, that's 15y. So 1 to 2 to 3 to 4 is that. So there's some written explanation on the solution document, so you can take a look at that. I didn't do all that writing here because I did a lot of talking, but you might have to, rewatch this video again and take a look at that, written solution stuff as well to help you with this. This will definitely help with the first 2 problems in the homework for sure. All right, send me an email, talk to me if you got questions.